Hi there, welcome to another video in the Python Snippets series. In this video we're going to take a look at list statistics. So what I'm going to do here is we've got another skeleton defined with, we're going to analyze lists in Python and we're going to extract statistics from those lists. And what I want to do is I want to generate a list of random integers to begin with that represent ages. So if I create a list called ages and I'm going to use the random module to select a random integer between let's say 20 and 50, and we're going to generate 10 of these for I in range 10, and then if we print that out we should get 10 random integers that we're going to use as our ages list for the rest of the tutorial. So the first step in Python has these three functions called max, min and sum, which can be used to actually get basic summary statistics out of a sequence data structure like a list or a set. So what I can do is I can call the min on the ages and I would get the minimum value in that list of ages. We can see that it's 21, whereas the maximum value is 50. So the maximum value is 50, which is actually the upper boundary of the random.randint function. So definitely the maximum value, 50. And finally we can actually compute the sum of the list using the sum function. And all of these ages, they sum up to 340. Okay, so that's how you get the maximum, the minimum and the sum of a list. And now I want to show you how do you actually get the average of a list. So that's very easy. The average is defined as the sum divided by the length of the list, length of ages. So I'll simply write the sum of ages divided by the len of ages, and that should give me the average age in that list of data. The average age turns out to be 34 years old, so that's how you get the average. Very simple, you sum up the list and divide by the length, and that's how you get the average. So next I want to move on to something a wee bit more tricky. That's the standard deviation. So what you do to compute the standard deviation is you take each item in the list, you subtract the average, and then you square that result. So when you know, let's say we take the first element 50, we subtract the average, which is 34, that would give us 26. Sorry, that's wrong, it would give us 16. That's terrible maths. So what we'd then do is square 16, and then we'd do that for every single element in the list, and we'd sum up all the squared results and divide it by n and take the square root. So that's how you get the standard deviation. Let's write the code to do that from scratch. So I'm going to say the sum of squares is equal to 0. We'll start with 0 and we're going to sum up each item in the list. So for age and ages, let's do a for loop. We are going to grab the sum of squares and we're going to add to that the result of taking that given age that we're iterating over minus the average, which I'm going to define up here actually. So let's just say the average is equal to what we computed here. The average is the sum of the ages divided by the length. So I'm going to take each age in the list, subtract the average, and then square that value. And to square something in Python, you can do this syntax. Two multiplication operators essentially means to raise to the power of. And once we have that, we can then do the next part of this operation, which is to divide the sum of squares by n. So sum of squares, which I've got copied, sum of squares, and I'm just going to recompute that, divide equals, and we take n, which again is the length of the ages. That'll recompute the sum of squares variable to be what it originally was, divided by n. And finally, to get the standard deviation, we take the square root of sum of squares. That's the final part of that operation. And I need to import the math module to do this. So import math, and that should give us a result which is 9.787. So the standard deviation of this list is 9.787. And I want to verify that that's correct, and here's another module in the Python standard library. It's the statistics module. It provides us with a couple of functions, the stdev standard deviation, and there's also the population standard deviation, 𝗦cie𝗰𝗶𝗹. I don't think I said that very well, but you get the picture. You can see it written here. So what the population standard deviation will compute the actual standard deviation of the given list. So I'm going to import the statistics module, and what I'm going to do is I'm going to verify that statistics.p standard deviation, my goodness, that's difficult to say, population standard deviation over the ages, I want to assert that that's equal to what I've got above, and I see that it is equal. Okay, so that tells us that this calculation we've done is actually correct. So the important takeaway here is that the Python module has a population standard deviation function that you can use over a list to compute the standard deviation of that list. And finally, just to show you another way of doing this, you can use the very popular NumPy library to compute the standard deviation with the standard function, and we just pass in the list there and we should get the same result back. So these are equivalent ways of doing it. Obviously this is a more laborious way. You have to write the for loop, you have to compute a sum of squares, you have to then take the square root at the end. There's a very handy statistics module that allows you to do that, and very often if you're doing statistics in Python you'll be working with NumPy, which means that you can use the functions available in that package. Finally, just as a little convenience, I'd like to show you how to rewrite this operation in one line, just to show you how that's done. So I'm going to comment all this code out, and let's see how to rewrite that in one line. So first thing to do in that task is I'm going to say we want to compute the for loop, the sum of squares. So to do that, I want to say the sum of squares is equal to, let's write the for loop part of that first. For age and ages, this is going to be part of a list comprehension. So let's say for each age in the ages we want to take the age, I'll keep the average around here, we've got that pre-calculated. So we take the age in that for loop that we're using, we subtract the average and we square it. So that will give us the sum of squares essentially. And then what we want to do with those sum of that gives us the squared value for each element in the list. We then want to sum that to give us a value, and that gives us this value. So that gives us the sum of squares. We want to then divide by the length of the list to get this part here, the length of ages, and that gives us a value here of 95.8, which is actually in statistics this is called the variance, when you take the sum of the squared differences between each item in the mean and normalize by length. And finally we can just take the square root over that to calculate the standard deviation, and we get the same result as before, but we get it in one line, and this is pretty cool. Any more complicated than this, then you would definitely not want to write things like that in one line. It's bad programming practice to be too complicated and do things like that in one line, but I think this is a nice compact way of representing calculating the standard deviation over the ages list. And as I said, the standard deviation is the square root of the variance. So just to demonstrate that, I'm going to use the statistics module again. We see that the deviation is equal to that value that we've already calculated. Now the statistics module in Python also has a variance and a p-variance function for the population variance. So I can then I can have a look at the variance, which I'll call VAR, and that's statistics module dot p-variance. That's the population variance of the ages. So I can look at var and I see that that's equal to 95.8. So I want to now assert that the variance, the square root of the variance is equal to the deviation. You see down below that does not throw an error. The square root of the deviation, square root of the variance is the deviation. So we can see that that's 9.78. These are the same. So essentially in statistics, the standard deviation is the square root of the variance over a data set. I think that's enough for this video. I'd like to thank you for watching. If you've learned anything or enjoyed it, please subscribe, and there'll be more Python tutorials coming up soon. Thank you.